you are asked to find the relative index of, refractive index of glass using a rectangular block of glass and a traveling microscope, a small amount of lycopodium powder and a piece of white paper cut to the size of the glass block are also provided. A letter X is marked in the middle of the white paper. Diagram of a traveling microscope that can be used in this experiment is shown in the figure. Part A. Identify the parts marked A, B, C, D and briefly state their function. We have to write name of the part and then we have to explain function of the part. A is the fine adjustment knob. Fine adjustment knob. The function is fine adjustment in vertical direction. We can adjust traveling microscope in vertical direction directly, or we can adjust vertical arrangement by using fine adjustment. When using fine adjustment knob, we can move vertically with a small distance. Then part B, focusing knob. Focusing knob. We can focus the object by using focusing knob. Or we can write it in descriptive method. We can get and clear image of the considered object by using the focusing knob. Part C, leveling screws. Leveling screws. We can level the microscope table. By using leveling screws. Then part D, split level. We can verify the leveling by using split level. Part B, before starting the experiment, while familiarizing with the traveling microscope, a student observed that the fine adjustment knob relevant to the horizontal movement was turned. The corresponding vernier scale did not move. Give the reason for this. Sometimes we can move the traveling microscope in horizontal and vertical direction, but vernier scales are not moving. The reason is there is a locking knob for the traveling microscope. It is not locked. Then we can write part B, locking knob is not locked. Part C, an enlarged figure of the main scale of the vernier scale of the main scale and vernier scale of the travelling microscope are shown. Calculate the least count for the travelling microscope in centimeters. Now we have to give the answer in centimeters. We have to find 2 points of coinciding, main scale and vernier scale. We can see that 0 is coinciding. Main scale 0 and vernier scale 0 coinciding. Then we can identify 24.5th value. 24.5th value in main scale is coinciding with 50. 24.5 coinciding with 50th value of the 50th part of the vernier scale. Now we can get number of vernier scale parts coinciding with number of main scale parts is 50. Then length of this part is 0.5 times 24.5. No, 0.5. 24.5 is the length in millimeters. Then we can get length of this part is 24.5 millimeters. Coinciding with 50 parts of the vernier scale, I will consider length of a part of vernier scale as x. Then we can find the x value. We can equal these two lengths. Then x into 50 should be equal to 24.5. Then length of a vernier scale part 24.5 divided by 50. Now we can write the equation for least count. Least count is length of main scale division minus length of vernier scale division. Length of main scale division is 0.5 millimeters. We have to subtract vernier scale division. Length of vernier scale division is this value, 24.5 over 50. But we are using in millimeters. Finally, I will convert the answer to the centimeter. Then we can write 0.5 means half minus 24.5 over 50. We can get the common denominator 50. 50 divided by 2, 25 into 1, 25 minus 24.5. 0.5 divided by 50. We can cancel out by 5, 0.1, 10. Then 0.01 millimeters. Millimeters to centimeters we have to divide by 10. Then it is 0.001 centimeter. Part B. What is the adjustment that you perform on the eyepiece before starting the experiment? We have to focus the crosswise of the microscope by using the eyepiece lens. Then we can write answer for part B. Focusing crosswise by using eyepiece lens. Then part E. Now you are asked to place the given piece of paper on stage G of the travelling microscope and obtain first measurement with the microscope using the mark X before placing the glass block. Write down the main steps in the experiment procedure you would follow to achieve this. We can write first unlock the microscope assembly, unlock the microscope and adjust the microscope until the image of X is seen. Then lock it and use the knob A or B. A or B is marked in the figure. Those are fine adjusting knobs to focus the image. First of all, we have to unlock the microscope. Then move the microscope to see image. Now it is not a clear image. Therefore, lock the microscope. Finally, we can adjust the microscope to see a clear image by using A or B knobs. In part F, relevant positions of the main scale and vernier scale corresponding to measurements mentioned in part E above are shown below. Write down the reading corresponding to the measurement in centimeters. Again, I will calculate the value in millimeters and finally I will convert it to centimeters. We have given an enlarged diagram. We can write reading equals to main scale reading plus least count into coincided vernier scale part. Main scale reading means the main scale value before the vernier scale 0. We can identify it by using given main diagram, not enlarged one. Vernier scale 0 is after main scale 46.5 millimeters. I am using millimeters. Then main scale reading is 46.5. Least count in millimeters 0.01. We can identify coincided part by using the enlarged image. It is 42. 46.5 plus 0.42. 2964. 46.92 millimeters. We can write it as 4.692 centimeters. When converting millimeters to centimeters, we have to divide by 10. Then part G, after taking the first measurement mentioned in part A above, write down the important steps in the experimental procedure pertaining to the other two measurements that you need to perform. We can place the glass block. We can place the glass block on mark X. Place the glass block on mark X and get the reading by focusing point X. we have to focus point X to the glass block. It is the first step. Then we can focus lycopodium powder on glass block as the second step. Then we can write spread lycopodium powder on glass block and get the reading by focusing powder. Part H, readings of the relevant three measurements obtained by another student when performing this experiment are given below. Using these three measurements, calculate the relative index of class. Refractive index of class. Now I will explain that how to get the refractive index by using three measurements. First we have focused point on paper. This reading is 4.606 centimeters. As the second step, we have placed the glass block on the point X and we have focused this point again and reading corresponding to the focus is 5.496 centimeters. As the final step, we have spread lycopodium powder on the glass block can. We have focused it. The reading is 7.206 centimeters. We know that refractive index is equal to the ratio between real depth and apparent depth. We can get the difference between these two readings to obtain the real depth. The height difference between this point and this point is the real depth. Then we can write real depth 7.206 minus 4.606. 6 minus 6, 0, 0 minus 0, 0, 12 minus 6, 6, 6 minus 4, 2. It is 2.600, 2.6. And when focusing this point, we can observe this point with the apparent displacement. Therefore, we can get this apparent depth by using the difference between this measurement and this reading and this reading. Then we can write apparent depth 7.206 minus 5.496. 6 minus 6, 0, 10 minus 9, 1, 11 minus 7, 4, 11 minus 4, 7, 6 minus 5, 1. 1.71, we can cancel out 0. These two values in centimeters. Then we can write the equation for the refractive index. Refractive index N is real depth divided by apparent depth. Real depth divided by apparent depth. Real depth is 2.6. We have to divide by apparent depth 1.71. We can write it 260 divided by 171. 1 1.5. You can get 1.5 as the approximate answer.